All right, let's do this. This is Brian. How's it going? We want to look at this problem from my Open Math. It's a two independent sample t-test. So what we have here, we're testing the claim that the mean GPA of night students is different from the mean GPA of day students. We have a sample of 23 night students and 29 day students, and their GPAs recorded below. We want to test the claim using a 1% significance level. Assume the population variances are unequal and that GPAs are normally distributed. So a couple of things. First off, the data is given to me in this table. And up until recently in StatPowers, you couldn't enter data in tabular form. So I just added the ability to add columns of data. If we go to StatPowers, click on columns, and actually while we're at it, let's change the precision to 4, because all my answers, it wants them in 4 decimal place precision. So I can name the columns. We can name GPA night and GPA day. And I'm going to go back to the table and copy this data, paste it, and you'll see one thing I need to do because blank or empty table cells in HTML documents, web pages, are not copied as anything. It's copied as empty space or nothingness. So I need to put these values over into the right column, not the left column. And I can just hit tab to move things over. Tab, 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 tab. And that's what I wanted. If I click on text areas now, you'll see all the data is in the right text areas. I can go ahead and I can click calculate now just to have all of the statistics and everything calculated for me. I can go down to the t-test for means, which is where I'm going to be doing this analysis. I can set my significance level to be 0.01 because that's the significance level for this problem. Anyway, let's go back to the problem and go through the answers. So first off, what are the correct hypotheses? So we were asked to check whether the means of night students differs from the means of day students. So that's mu1 is, say, night students equal to mu2. This is a null hypothesis, assuming that there's no difference between the two of them. And then the alternative is that they are different, so mu1 is not equal to mu2. Based on these, we look at a test statistic. Now, for this, we were told we want to assume that the population variances, let's see that right there, assume the population variances are unequal. And so if the population variances are unequal, then, we should not pool variances. So if you go over here, there's results from pooled variances and unpooled variances. And unpooled variances is where we want to get our test statistic from. The test statistic 1.2235 and the corresponding p-value of 0.2269. So with a p-value that large, especially with a significance level of 0.01, we want to fail to reject the null hypothesis. There's not enough evidence to suggest that the means of the two groups are different, and that's exactly what we want to say. There is not enough evidence to support the claim that the mean GPA of night students is different from the mean GPA of day students. So that's going to be our conclusion. That's the hypothesis test and the p-value and everything, and that's how you do it. Let's just submit and make sure everything looks good, and everything does indeed. All right, anyway, I just wanted to demonstrate this two-sample t-test in StatPowers and leave it at that. All right. Hi, it's Brian. I want to go through an Anova example using StatPowers now. So Anova is a method for comparing different groups when you have one or possibly more than one factor that differs between the groups. In StatPowers at the moment that I'm recording this, we can handle one factor Anova tests. So what we have here is an example. Let's read through it. So students enrolled in developmental mathematics classes at a community college are encouraged to go to the Math Tutoring Center for help with their homework. Okay, so let's try to cut to the chase here. We've got students in 4 different study groups. Okay, so each of the study groups have the number of days that the student from this study group visits the tutoring center. All right, so we have all these numbers now for these different groups. In StatPowers, this is multiple independent groups. We're going to go to under analysis, quantitative n sample, 3+ independent. So that's 3 or more independent samples. Now, I want to show you the method. Now we can enter data either in individual text entry areas like this, or we can add it under columns, and that's what we're going to do. I'm going to select that there's 4 columns, and you can see that they're just automatically named Group A, Group B, Group C. All right, I'm going to go over to the problem over here, and I'm just going to copy, and I'm going to paste the data into my table, and the data's in. So if I click on text areas, you'll see that the data has been put into the text areas. So what we're asked to do is to perform an ANOVA, a 1-factor ANOVA test. So you will want to click calculate now just to have the data, have it calculated, and then go down to ANOVA test for different means. Now, this is going to give us all of the output from a standard ANOVA test. This problem is asking for a few pieces. It's asking for the mean squares between, so that's the table. This is a standard ANOVA table. The between mean squares is given here. All right, 122.923. We're also given the F ratio of 3. Oops, I think I pressed enter. 3.127. So no surprise, these answers are wrong because they were left blank. And I have to do the p-value to 4 decimal places. So remember, in StatPowers, just go up to the settings, change precision to 4 decimal places, and I'm not going to get, if I have more than 4, more than necessary, that's fine. But the p-value is given as the significance of the f, 0.0335. This is a pretty small p-value, especially considering I'm using a significance level of 0.05. So we'd say that the evidence does suggest that the average daily visits are not all the same. Like, some of the groups are different. And so what we're going to look at is see if any of the groups have outliers. This says to use SPSS, but I can create box plots in StatPowers. Click on box plot, and we can see Group A, Group B, Group C, Group D. It looks like Group B really has some extremely extreme outliers. Group B and Group 2 are one and the same. So Group 2 does have extreme outliers. Any group with extreme outliers, delete these values and rerun ANOVA. Now, Group A does have some outliers, but they're not so extreme within the context of the data. I'd say these are really, really extreme. Those are the ones I'm going to focus on. It says to remove the outliers. So going up to Group B, and I can see that it says that we have 36 visits, 37 visits. Those are getting deleted now. And now I want to rerun the ANOVA, so I'm going to click calculate now. And I can see now we have let's see, the data, the output from the ANOVA is much different now. The mean squared between is now down to 7.6832, or 7.683. F ratio is 1.0931, and the p-value is now 0.3609, which is not a significant p-value. So there is now not enough evidence to suggest the average daily visits are different. And so the conclusion here is the outliers did have an effect on the conclusions of ANOVA. So sometimes the outliers are going to make a big difference, especially when there's just a handful of extreme outliers. Let's just check and make sure everything is Yeah, absolutely correct. So that's how you can do so it's just an overview of doing a one-factor ANOVA in StatPowers. Okay, I will stop that here. Bye.